Thank you, Kevin, and good morning, everybody. It's great to be part of KPMG's Partner Conference. It's a real honor for me. There are so many emerging technologies that are available right now and over the next few years. It's just incredible, and they're going to provide a lot of opportunities for all of you in this room to offer advisory services to your clients. So I'd like to take you on just a little bit of a ride into the future and put it in the context of advisory services. So let's start with something that some of you will be familiar with, augmented reality. How many of you have played with augmented reality glasses? Any of you? A good few of you, right. You know that what it's doing is literally superimposing the real world in front of your vision, but letting you see the real world too. And it has lots of uses. Consumer to consumer applications where you might be in your living room and have a floating television or a hologram chef, to business applications where you're looking at something in a magazine and it literally pops off the page and lets you twist and turn it and look at it from every angle. But most importantly and interestingly, from an industrial perspective, a lot of the companies that I talk to are interested in augmented reality, but not really sure how to quite integrate it in with their business. Let me give you one example that comes out of Spain. This is a company called Acciona Agua. They're a water treatment company, and they're using augmented reality as well as its sister technology, virtual reality, where you're immersed in a digital world in their actual real-world operations. So what they're doing with virtual reality is they're using it for training. They're taking their staff and allowing them to play around with all kinds of water treatment situations and get in trouble and not have any real-world effect. And they're finding that this actually has a much better memory recall than going through other types of simulations. But what's most fascinating is how they're using it in the real world, where they're equipping their workers with augmented reality glasses that in effect take the SCADA system from the water treatment plant and allow them to carry it with them whatever they're doing or working on. So imagine looking at a row of pipes and you can see the temperature and the water pressure and superimposed a gauge that tells you which way to turn things, and you have video that allows you to collaborate in real time with people in your back office. This is just one example of how a company is already bringing this technology into their firm, and there are a lot of others. Most of them are using smartphones or pads right now as their way of bringing augmented reality into their services and in particular consumer offerings, but there's a world of opportunity out there in helping companies to do that back-end integration so that they can use augmented reality to be more efficient or more safe in their operations. Many of you would have heard the term smart city. Raise your hand if you haven't. Okay, don't think anybody actually raised their hand. So a smart city, what I mean by that is literally taking on board information from all of these Internet of Things devices that are being deployed in lots of different places and turning it into actionable insights. A good example comes from Italy. Trenitalia has equipped their trains with all kinds of sensors. And rather than doing maintenance on a scheduled basis, they are now doing maintenance when the sensors say that a particular part needs to be looked at or needs to be changed out. They have a budget of over 1 billion euros, and they're saving between 8 and 10% per annum by adopting real-time actionable insight coming from sensors. In Sydney, where I live, there's a project called Mousetrap, and it's a sensor that is on Sydney trains that is able to sniff out the smell of permanent markers or spray paint. In other words, being able to tell if someone is about to do a graffiti act. And as soon as it sniffs it, it turns on a CCTV camera, it goes into the train's office, and someone, a human, can look at this and decide whether a train is about to be defaced. And guess what? It also feeds into the train's police, and they can catch the perpetrator in real time, preventing graffiti. In Chicago, where I was at a couple of months ago, there's another project called the Array of Things. And what they're doing is putting what looks like beehive clusters of sensors on 500 spots around the city in effect creating micro neighborhoods across the city of Chicago. And they're measuring all sorts of things: temperature, barometric pressure, all kinds of pollutants, noise, vehicular traffic, pedestrian traffic, you name it. And they're turning it into an open source database. They're using it for planning of city infrastructure, but by making it open source, they're also allowing third-party developers to come up with cool ideas. For instance, an application that would allow someone who has asthma and wants to walk to and from their house and work to literally navigate a path in real time that has the least number of pollutants and also has other people around so that it's safe to walk at. So it's all about taking information from these IoT devices and turning it into actionable insights. And cities around the world need advice on how to do this. Going into the future, it gets even crazier, because what we're going to see, likely by the year 2050, are self-repairing cities. There's a project that's being run out of the University of Leeds in the UK, where they're looking to build fleets of tiny little robots that will act like the white blood cells in our own bodies and make the city a living organism by sensing defects and fixing them before they even become major problems. One of the modalities that they're looking at are little flying robots that will perch on things like light posts and be able to do repairs like switching out a light bulb, or maybe someday even fixing an electrical wire. Another thing that they want to do is to prevent potholes, to make them ancient memories. And when I first asked the scientists involved in this project, how are you going to do it? My initial thought was, well, you'll probably have fleets of flying robots just scanning the streets and seeing if a pothole is in the making. And he said, actually, what our end goal is that we would like to collaborate with the driverless car industry, because these cars are going to be outfitted with all kinds of sensors and high-definition cameras. And we'd love to get real-time feeds on what's happening in the streets and then send the robots out to fix the defects. But in the meantime, they're designing something, and they're in experimental stage. So they've designed 3 little bots. The first that actually flies along like I thought and scans the streets for a potential defect. The second little flying bot lands and starts doing the digging and the pre-repair work. And then the third bot has an onboard 3D printer that prints asphalt and fixes the pothole in the making. And they want to go even further than that. They want to design robots that go deep underneath the city into boreholes and are able to monitor what's happening underneath the city in real time and eventually be able to fix it. This sounds really science fiction-y, but guess what? In Sydney, on the Harbour Bridge, we've had working robots that are completely autonomous for 9 years, thanks to the collaboration of New South Wales Roads and Maritime and the University of Technology, Sydney, where they wanted to solve the problem of how do you make the Sydney Harbour Bridge safe, and in particular solve the grit blasting problem, which can be dangerous to humans. So they designed robots that are completely autonomous, can map their way through this complex steel infrastructure, report into this GIS system in the bridge system, and let the engineers decide if maintenance needs to be done, and then the robots can do the maintenance. You're going to start to see a lot of cities start looking at this whole concept of self-repair and how do we use robotics to maintain our infrastructure. This picture I took at CES last year, it's a prototype from Toyota, and it's what they think a car might look like in 2030. Well, wouldn't that be cool if we all drove around in cars like that with dove wings and great lights and everything else, and AIs that are your best friend? Well, the reality is that in talking to auto manufacturers, every single one of them around the world, bar none, is investing very heavily into autonomous vehicles and into electric and hybrid electric vehicles. And they're going to be coming out in car year model 2020 or 2021 in a big way. And every single one of the auto manufacturers are also investing very, very heavily in artificial intelligence and in equipping their cars to do a whole lot more than just be vehicles that people own and carry people to and from work. One of the things that we need to look at from a policy perspective is that these cars are going to be electric or hybrid electric, but if I look around Australia, there are very few EV charging stations. We need to do something about that, or suddenly we're going to find ourselves in a position where the cars that are being manufactured are not cars that we're able to top up and fill with electricity here in this country. Another opportunity that is going to arise from driverless vehicles is what I'm calling a vehicle-to-vehicle network. And right now, autonomous vehicles have lots of sensors and cameras, and they use them to navigate their way in the world. But where this is going in the next couple of years is that they will not only be communicating with the driver or the people in the car, they'll be communicating up to a cloud-based traffic network that is able to send messages from car to car. So let's say you're driving a car and you hit a pothole, you'd be transmitting to the car in back of you, hey, there's a pothole, and the car in back of you would go around it and so on down the line. But it gets even better than that, because what will happen with city infrastructure like traffic lights and stop signs and yield signs and everything else is that they will be outfitted with IoT sensors, and these sensors will be broadcasting the speed limit here is 60 kilometers an hour. Say goodbye to traffic infringement revenue. That's going to go away over the next couple of years. These vehicle-to-vehicle networks are not yet designed. This is an opportunity in the making, and departments of transport around the world are grappling with how are we going to do this? What kind of communications network are we going to either design or use? Who do we partner with? Who are the people that are going to help us with the policy and the regulations that go around this? And frankly, with driverless cars, there are a lot of ethics that go into it as well. For instance, if there's an unavoidable accident, who's at fault? Is it the car, the person who's driving but actually is in the back seat because there's no steering wheel or brake pads or accelerator? Is it the person who designed the software, the car manufacturer? I think they're going to be equipped with black boxes, especially as we're in this transition mode where cars are semi-autonomous. People drive it sometimes and the car drives itself another time. And there are going to be other implications as well. Once cars start doing self-driving, they're not going to be sitting in parking garages during the day or sitting in your garage at home. They're going to go off in ride-sharing mode. It's going to have a ripple effect through society. And there's going to be a lot of advice and planning that's required around this whole transition to our transport infrastructure. Another major disruption in our transport infrastructure is a new transport technology called a hyperloop. How many of you have heard of it? Yes, I've got a really tech-savvy audience here. For those of you who haven't or haven't had a good definition, basically a hyperloop is a tube where the air has been sucked out so that it's at near vacuum, meaning that there is no friction, and conceivably you'd be able to hurdle pods of either people or cargo through it at an average cruising speed of 760 kilometers per hour and a top cruising speed of 12 or 1,300 kilometers per hour. Elon Musk came up with this idea in 2012 and wrote a paper in 2013 and purposely outsourced it. So there are a number of companies that are now in the process of designing Hyperloop test tracks. This is one in Nevada from Virgin Hyperloop One. Sir Richard Branson bought into it. There are others, Hyperloop, Transport Technologies, and Elon has SpaceX getting into it. But basically, these are already being trialed, and the speeds that they're achieving aren't the top speeds yet, but they're proving to be very, very fast, and they're proving to work. There's one proposal in Australia in particular that's looking to put in a hyperloop between New South Wales and Victoria going through Canberra that basically would allow Sydney and Melbourne rivalry to completely stop and become a megacity, much like you'd see in America. And imagine that if you live in Newcastle and you work in Sydney, instead of commuting for 2 hours, you can get there in 10 minutes. Or you can get to Canberra in 17 minutes. Or you can get from Canberra to Albury-Wodonga in 9 minutes. Imagine the impact of something like that on regional life. You'd actually be able to afford to live in a beautiful property and work in a CBD if this kind of technology were to become available. And there are a lot of countries around the world that are very seriously considering hyperloops. The first one is likely to come live in a commercial sense in the year 2021. That's only 3 years away, and it will probably be in the UAE between Abu Dhabi and Dubai, where they're looking to cut an hour-and-a-half drive down from an hour-and-a-half down to 12 minutes. Sir Richard Branson also put out an idea of putting in a hyperloop between Gatwick and Heathrow to do like a super airport in the UK. And not to be outdone, Elon Musk came up with another company called the Boring Company, as in tunnel boring. And he is looking to have, if you like, multi-dimensional transport, 10, 20, 30 levels beneath the city with hyperloops inside of them. It sounds so science fiction-y, but he's already been given digging permits in Washington, D.C. and in Baltimore for the potential hyperloop that will connect Washington, D.C. through Baltimore, through my hometown of Philly, all the way up to New York City, taking what is at least a 6-hour drive down to 29 minutes, if you can imagine. But once again, huge policy and regulatory impacts here. Many of you are Australian. How many are you from Australia, just out of curiosity? Yeah, a good few. Have you heard about WestConnex and all the, neighborhood riling that's going against that? Imagine having tunnels 10, 20, 30, below ground. There's going to be a lot of interesting discussions around this. Another technology that is going to have a major impact on our world of the future is drones. And we already see drones being used in a lot of areas, in videography for real estate, in asset inspection for telecommunications or electricity utilities. It's being used by insurance companies to help assess flood or fire damage. But most interestingly, it's also being used as a potential personal transport. This bottom picture on the right is me with the world's first prototype flying taxi. It comes out of China. It's called the eHang 184, and it was a working prototype when I saw it last year. It's able to carry a single passenger at up to 100 kilometers and about 23 minutes flight time. But there are a lot of companies that are working on flying taxis. In New Zealand, the government in stealth mode for the last 18 months has been working with a company called Kitty Hawk, and their flying taxi is called Cora. It's pictured here. It's completely electric and completely autonomous. It takes off like a helicopter, so it's got vertical takeoff and landing, and then it flies horizontally, and it lands vertically as well. They're already engaging in real-world trials with the government, so in conjunction with the regulators, and they're hoping that they'll have a commercial service within the next 3 years. That's 2021. And the way that you order this taxi is through an app. You literally say, I want to go from point A to point B, and it will take you there at about 200 kilometers an hour. I believe it has about a 100-kilometer range, and it can seat 2 people. A lot of companies are getting into this, including Uber. Uber Elevate is another example of a company that is getting into flying taxis. And this is their version, and they're looking to have tests going in Dallas, Fort Worth, Los Angeles, and Dubai by 2020, commercial services by 2023, and they're also now opening it up to potentially do services in 5 other countries, including potentially Australia in either Sydney or Melbourne. And in Sydney, what they're looking at is being able to get from Central train station near Haymarket to Manly in 8 minutes, as opposed to a 110-minute UberX drive. So flying taxis, something that sounds just like it's out of a science fiction movie, are looking like they're going to be part of our reality over the next couple of years. There are huge, huge regulatory challenges that we will have to overcome, as well as safety challenges, and of course a lot of advice that will go around it. Just like we will have vehicle-to-vehicle networks that govern autonomous vehicles on the ground, we're going to see highways in the sky and vehicle-to-vehicle communications and air traffic control that govern this. In fact, as part of Uber's test in the United States, they've partnered with NASA, who's taking the lead on all of this, by the way, and designing an air traffic control system. Amazon is actually the first one to propose an air traffic control system in 2015 because they want to do deliveries using drones. And what they're doing is saying that the higher airspace, up to 400 feet, would be segmented and able to be used by drones that are equipped with lots of sensors and are completely autonomous, but the lower airspace would be used by drones that are manually controlled in line of sight, and there'd be no fly zones as well. There are so many challenges and so many opportunities that come with this, and it's a great area for, I think, KPMG to become involved in policy and in advising government clients all around the world, and also corporate clients. Because think about it, if you've got these flying taxis, you need places for them to land and to be able to take off or to drop off packages. And there are noise control issues, and there's black box issues if something goes wrong, and safety issues. And is it going to be CASA that takes responsibility, or some new agency, maybe the new space agency here in Australia? In the US, it's not the FAA, it's actually NASA that's taking the lead. And then there's artificial intelligence, and I know that was high on your list. If I had to pick one, just one technology that's going to impact every company and every person on this planet, it would be AI. And many of you may be surprised that work on AI started all the way back in 1956. And early AI, they basically looked to write in software the decision trees that professionals would use in making their judgment calls. Didn't work out so well. In 1980, they started to use a technique called machine learning. And with machine learning, it's a combination of feeding an AI data, but also hard programming things like the shape of a stop sign and the fact that it's red and has the word stop in it. In 2010, things got really interesting with a technique called deep learning, and that's where we're feeding massive, massive data sets into AI, and it starts to teach itself. Now, when I talk about AI, I'm not talking just about machine learning and deep learning. I'm also talking about natural voice language recognition, image recognition, facial detection, emotion detection, chatbots, smart robots, driverless cars, and so much more. Another aspect of AI is what you would call robotic process automation. And JP Morgan, the biggest bank in the US, has already embraced this in their operations. They have an AI that they call Coin, and it looks at their wholesale loan agreements. So typically a wholesale loan agreement would involve 30 hours of work by a senior loan officer and a lawyer to assess this document. Coin is able to do it in a matter of seconds. They do 12,000 plus of these documents a year, and they estimate by using Coin, they're freeing up over 360,000 hours of professionals, and they want to not get rid of people, but actually use these smart people in their organization for much more meaningful value-added tasks. And that's a really important message, is that AI is, if you like, a cobot. It's taking the drudgery and the repetitive tasks out of the equation and allowing you to free up human resources to do the things that we humans are really good at. There are lots of examples of AI, but let's talk about another big opportunity in robotics, and that's robots as a service. This particular picture is about using it in the agricultural sense, and the robots here are from the Australian Centre for Field Robotics, based out of the University of Sydney. They have the biggest and best field robotics organization, I think, if not in Australia, perhaps even the world. And they're able to sense all sorts of things in agriculture, pests, nutrients, fungus, moisture in the soil, you name it, being able to harvest things, being able to literally sense things from the air or the ground that a human could not possibly do. But if you think about farms, it doesn't make sense for individual farmers to buy lots of robots to do really specific tasks. It actually makes more sense to be able to offer it as a service, combine it with cloud analytics that talk about weather or crop yields or similar situations either on a particular farm or other farms around the world. And it's not just agriculture. We're going to see robots as a service in a lot of different areas. Already I know of companies that are offering services to utilities like inspecting electrical wires or going into decommissioned water pipes and seeing whether the condition of the pipe really warranted decommissioning it, or actually being able to go into mining and be able to look at dangerous situations there. This whole idea of as a service is taking on a whole new meaning when you start bringing robots and third-party databases into the mix. We're also going to see science as a service. Right now, doing scientific experiments is really expensive and really hard because of the equipment you need. And there are a lot of contract research organizations like Harvard and universities and so on that loan out their equipment. But it's very difficult for organizations to know who has what and who is able to do a particular kind of experiment. So there's a company that's actually Science Exchange that's a platform-based company that allows people who want to do scientific experiments to literally post what they're looking to do and have these CROs bid on them, and they manage all the contracts, and you just basically write up the scientific protocol and they carry it out for you. But once you get the data back, you still need to do something with it because it's masses of data. And there's another company called Agave that is basically using AI and cloud-based computing to do all kinds of calculations for you with this scientific data. There are a couple of other companies that are looking to combine the two and even let you remotely use the scientific instruments and cloud computing. But we're going to see things as a service that today are not even thought of. This is just one example. Back to AI. I mentioned speech as one of the aspects of AI. How many of you talk to your phones, to Siri, Cortana, OK Google? Anybody? A few. How many of you have one of these gadgets in your home, maybe an Amazon Echo or Google Assistant? Guess what? They're always on, they're always listening, and they are transcribing and recording data. I had a funny situation happen to me about a month ago. I was in America having a business conference with one of my clients over there, and she had a home office. I did not realize that she had an Amazon Echo. And 3 times during our conversation, Alexa interrupted us to say, "I'm sorry, I didn't understand that." Which is really weird because there was nothing in our conversation that mentioned anything close to Alexa. And these digital assistants are getting integrated into the software stacks of the computer systems that we buy, of the phones that we use, and how do we know where this data is being used and what the business model is of the company that is collecting this data? And in particular, in a business sense, how would you know if someone in a meeting has one of these digital assistants on their computer or on their phone and you've suddenly leaked confidential information? There are some really big challenges around the use of digital assistants. AI is fantastic at crunching data. This company called Scream AI is a dedicated AI company. I found out about it a few weeks ago because I had a LinkedIn connection from the CEO of the company. I haven't had a chance to have a chat with him yet, but I have looked very closely at their website. They claim to have information about 3 billion consumers, about 450,000 different consumer traits, over 100,000 brands. Their target market initially is in the finance area, and they claim to have detected over $14 billion worth of illicit transactions and fraud, have even claimed to detect terrorist cells in the making. But if you look carefully at this picture, which is actually a screenshot that I took from their website, they're saying that they get data from sources like, tracking search activity and reading, your news content. How are they getting this information? I've got some real concerns about privacy aspects and how this data might be used. How many of you have heard of the new regulations in Europe called GDPR, General Data Protection Regulation? Yeah, most of you probably would have. And EU is taking a different stance than has been the de facto norm. In the EU, right now, if you have a data breach, you are in big trouble unless you notify authorities within 72 hours and actually haven't had an issue. If you've had an issue and it involves EU citizen data anywhere in the world, here, Canada, doesn't matter where, if it's EU citizen data, it falls into the auspices of this law, then guess what? You can be fined 20 million euros or 4% of your global revenue, whichever is higher. And there are many lawyers that I've spoken to that think that this data opt-in is going to become the new model, rather than the model of whoever just happens to collect this data is the one who owns it. Yet here we are in Australia, we've got this new My Health initiative where people are being forced, unless they actually opt out, to literally turn over all of their health data to the government and over 12,000 organizations and 900,000 people who have access to it. We've got a bit of a disconnect between what's happening with data ownership in different parts of the world. And there are going to be a lot of governments that need advice on how do you reconcile what's happening in the various parts of the world. And then there's facial recognition, and it's getting so good and so fast. There are commercial products that can literally pick out a face of an individual from 1.6 million faces in a third of a second. That's fast. And not only that, but it can pick out the emotions of people as well. And that has a lot of implications. First of all, when it comes to facial recognition, it depends on how that deep learning database has been trained, because it turns out that most of these databases are trained on white male faces, and they can sometimes make really horrible mistakes. There was a group in the UK that monitored what was happening with some police use of facial recognition, and in just one day they found a number of instances, including the misidentification of a young woman with a bald man. I mean, you've got to admit the two don't look alike at all. And then it gets to video. And here's where it gets even more interesting with artificial intelligence. There's a startup called IC Real Time. They've got an AI called Ella. It's able to take CCTV camera feed from one camera up to several thousand, and in real time, using natural text-based language, allow you to scan these CCTV feeds for characteristics like man in a red shirt or a particular car model or a range of different things, and pull up the appropriate video. And by the way, there's going to be a major bandwidth tsunami happening, because right now we've got high definition as our standard. 4K, which is basically 4 times the number of pixels, is coming already in monitors. I've got it in my monitor. You might have it in yours. It's coming to TVs. In Japan, 8K is going to be broadcast at the end of this year. By the time we go out about 5 years, we're going to be looking at potentially 32K type of resolution at a hologram that is so real that if someone was standing next to me as a hologram, you would not be able to tell the difference between me and them, what's real and what's not real. The NBN or any other communications network is not going to be able to cope with that kind of huge, huge bandwidth. But it's easy to trick AI too. I can jiggle less than 1% of pixels in a picture, and to a human eye, you can't tell the difference, but to an AI, it will make that cute little doggy into an ostrich, or take that pyramid and the AI will think it's an ostrich. What do you think would happen if you tweak something and it's a commercial aircraft and somebody nefarious tweaked that image and it looked like an intercontinental ballistic missile? That would not be a good outcome. So we need to be careful with how we use facial recognition and image recognition. There's something even scarier that's happening, and that's something called deep fakes. How many of you have heard the term deep fake? Anybody? A few, yeah. It's a montage of deep learning and fake news. And what they are doing is that with artificial intelligence, you can take a video of any person and literally put over the skin and motions of another person. In this case, it's Alex Baldwin doing a performance of Donald Trump on Saturday Night Live, and somebody uploaded a picture of the real Donald Trump superimposed on Alec Baldwin's performance, and then you see a researcher having a good play with Vladimir Putin. But imagine if you got a video conference from the CEO of your company telling you to release funds to a particular organization, and the voice was modulated so that it sounded like the CEO of your company, and there's software that can already do this. Or it's the CEO of your company admitting to a crime or something bad that's happened in your company. This is a big problem, but luckily, with AI, we can combat this with anomaly detection. Everybody has particular gestures. We can pick these things out. And blockchain might be another one of those technologies that we use to be able to fix this, because we can check the provenance of where something was filmed. And if you look at something that might be President Donald Trump and you see it was filmed in a basement in Kiev, you can pretty much bet it's not the real Donald. We will see AI cyber attacks, though, and some researchers are predicting that we're going to see the first digital assistant virus either at the end of this year, beginning of next year, where it's been silently sitting in your digital assistant, learning your patterns, learning who you trust, and then impersonating somebody and having you take actions that you wouldn't normally take because it's embedded itself so deeply into your systems. And there's likely to be warfare, if you like, between AIs and AIs fighting each other, because it's going to be happening so fast that no human is going to be able to keep up. And then we've got quantum computing, and this is where we get really, really weird and wonderful. How many of you could give me a definition of quantum computing? Anybody? Very few physicists in the room, and I'm not one of them either, but I love this stuff. But basically with quantum computing, it goes back to Schrodinger's box. How many of you have heard of that experiment where the cat is both dead and alive, right? Well, with computing, it can be both a 0 and a 1 at the same time. And because of this, you can compute much faster. I have friends that are quantum physicists, and I was talking about this with one of them a few days ago. And the way that I picture it is, if you can picture a pole, you know, where one of the poles is a 0 and another is a 1, but you've got all these other states around an electron, that's how you get this quantum computing, where you can actually have multiple states at the same time and use it to compute. It's quantum entanglement. And with quantum computing, IBM has already come out with a computer that is capable of doing 50 qubits. And once you get to 4,000 qubits, there is no encryption available today that you cannot break, including blockchain. But I have friends, physicists, that are working on quantum blockchain, where everything is quantum entangled in light and is completely unbreakable. And this is something to keep your eye on, because blockchain is really big. Quantum blockchain is going to be even bigger. How smart can AI get? Well, if you talk to AI researchers, they would say they would not put an upper limit on it. I would not put an upper limit on it. At a conference last year, half of the AI researchers thought that AI could reach general human-level intelligence by the year 2040 to 2050, and 75% of them thought that 90% of them thought it could happen by the year 2075. So AI is going to keep getting smarter and smarter and smarter. Right now, I reckon it's about the age of about a 2-year-old, and getting smarter all the time, but we need to use reinforcement learning techniques and imitation learning techniques to train AI. And as you said in the video before I came on, we're going to see AI as cobots, and we need to train AI with ethics and to actually work alongside of us. So going into the future, what does that mean for us? Are we going to take technology into our bodies? Well, we probably are, and it's probably going to start with something called smart contacts. And this is where we'll have contact lenses that are removable. When they come out, they'll most likely be made of graphene and be completely translucent. These pictures are from Google. The big one is from 2014. The little one is from 2016. So you can see how it's getting more and more transparent. And if you can imagine, you've got these smart contacts in, and you've got augmented reality displays. I'd be looking out at this audience, and I would know every one of your names. I'd be able to pull up your social profile. And what's even more interesting is that the pharmaceutical companies are getting involved in this too. So we've got a combination of augmented reality, ICT, and pharmacology all converging together. And in the pharma sense, one of the things that I think is fascinating is something called autofocus lens. So I need reading glasses. I'm constantly popping them on and off. I would love to have one of these where I don't need reading glasses anymore. I get facial recognition. I get all kinds of value add. There are other medical applications that can measure intraocular pressure in your eye to prevent glaucoma. The list goes on. In like a 5 to 7 year time frame, we're likely to see app stores where you can download biotech or ICT applications for your smart contacts. And it goes beyond that into brain implants too. This is just a real short video from UC Berkeley. They have designed something that they're calling neural dust. Right now, it is millimeter size, and it's funded by DARPA out of the US. DARPA has let out 7 contracts. One of them was to UC Berkeley. And what they want to do is literally have nano-sized implants that they can put into soldiers to help regulate them from pain or post-traumatic stress. Think about that for a moment. You know, we're talking about employers putting implants in your body. So this is where UC Berkeley is at now. They have these millimeter-size implants that they're testing with rat nerves, and they're using ultrasound because it is not biologically invasive. And they have been very successful at being able to detect the electrical activity in rat brains through this particular neural dust technology. And the next step is to take it down to nanometer size. And if you can imagine, there are some amazing medical benefits like being able to control prostheses or being able to monitor your organs in real time. But then, of course, there's also the dark side of what if someone gets a hold of the controlling factor of this and suddenly, instead of stopping pain, causes you to be in pain unless you do something that you don't want to do. And this is likely to be on us. This is just one example of many, many, many brain-machine interfaces. And it's yin and yang, always good and bad, good and bad. You never know quite which it's going to end up with. And lastly, just to leave you with one closing science fiction thought, in the 2030s, one way or another, it's likely that our brains are going to be connected directly to the World Wide Web. Ray Kurzweil thinks it's going to be through 3D printed nanobots that get injected into the capillaries in our brains, connect us directly to the web of whatever the 2030s is. You won't be searching Google. You'll be thinking a question and getting an answer. If you want to solve a problem, you'll be using computer horsepower from the cloud to solve the problem. If you need a new skill, you'll download it like Matrix in, Trinity in Matrix, or better yet, you might even stream it, and you might have nanobots in your body fixing things as they go wrong. Look, there are so many opportunities in the world of emerging technology. The future is really bright for KPMG in terms of advisory services, both in terms of helping clients to understand how these technologies can be integrated into their companies, but also on the government and the regulatory side to start thinking about what the implications of these technologies are and how do we revamp our transport systems in particular. I'm going to be hanging out through lunch, so I invite you to come and have a chat with me, connect with me on LinkedIn, and if there are projects that you'd like to collaborate with me on, I'd be delighted to chat with you about it. Thank you so very much.